Hi guys, welcome to Tech Compass YouTube channel. In my previous video, I have discussed about history of computing. For that, I have received mixed feedbacks, where one of my friend was saying that you have to explain more about the topics, what you are presenting. Yes, absolutely, what he is saying is correct in his perspective. But please understand one thing here. My intention is to highlight the audience who wish to become a good developer that before becoming a good developer, there are very important things we should know to lay the strong foundation to build our programming skill. Because I see less people talking about it in the YouTube channel. So my intention is to show that the right direction to step up to become a good developer. In my videos, I will not try to replicate the content which is already well set in the other YouTube channel or in any other site because it is waste of time. But I would like to highlight the important things to know aligned with the topic whatever I am posting. Hope you understand my point of view. Let's move on. Today I am going to discuss about Boolean algebra and then binary number system. So, why to know about Boolean algebra? There are mainly two reasons which I wanted to highlight here. It is the foundation of digital revolution. Most of the electronic devices designed follow the principle of Boolean algebra. And the secondly, Boolean operations. All electronic systems except a few designed to work based on Boolean operations. Also, in programming languages, we also use bitwise operators that also require the understanding of Boolean algebra. And there are other mathematical problems like set theory and statistics also use Boolean algebra, which can be used when we work on data science and other statistics related projects. So let's move on. This is with respect to digital revolution. In the digital world, whichever the electronic devices uses registers, arithmetic logic units, control unit, and memory are using logic gates. Logic gates are electronic circuits that can be used to implement the most elementary logic expressions, also known as Boolean expressions. The logic gate is the most basic building block of electronic circuit. Here we are talking about logic gates because it follows Boolean algebra. This is with respect to Boolean operations. While learning programming languages operator, we learn about something called bitwise operator. To know how that works, we need to have a basic understanding of Boolean algebra. This is a snippet I have taken from the site mentioned in the URL. Look at here. What they are saying is that logic is a system of thinking that enables one to make decisions. Computers have their system of thinking too. It is called digital logic. And the digital logic is the foundation of modern computers. Please go to the site if you want to know more about it. Now, here comes the person behind the digital revolution, George Boole, the British mathematician whose work on the logic laid many of the foundations for the digital revolution. His development of Boolean logic in 1854 has significant impact to computer history because it contributed to the circuitry systems of the modern day computer. In mathematics and mathematical logic, Boolean algebra is a branch of algebra in which the values of the variables are the truth values, true and false, usually denoted 1 and 0 respectively. A computer can represent the binary digits 0 and 1 mechanically with wheel or a lever position or electronically with voltage or current. The underlying math remains the same. Just three operations, and or not, can perform all logic functions. For decades, Boole's idea had no apparent practical use. His work was largely ignored until applied by Claude Shannon to telephone switch design in the year 1930s. Today it is called Boolean algebra, a foundation of digital logic. Putting Boolean logic to work. Claude Shannon encountered Boolean's idea in a college philosophy class in the 1930s. He recognized its value for real-world problems. Shannon's 1937 MIT master's thesis, a symbolic analysis of relay and switching circuits, applied Boolean algebra to the design of logic circuits using electromechanical relays. What makes a computer? It's built from simple elements called gates, made from mechanical or electronic switches. They operate according to the Boolean algebra. To determine the output signal 0 or 1. To save a value in flip-flop, a storage unit from several gates. Three basic gate types are AND, OR, and NOT, but others such as NAND can by themselves form any computer circuit including arithmetic, memory, executing instructions. In regular algebra, values of variables are numbers. Possible operations are addition, subtraction, multiplication, and division. For example, x plus 2 is equal to 4. It's a simple example for a regular algebra expression. In Boolean algebra, values of variables are true or false. The possible operations are logical operations. There are mainly three operations: AND, OR, NOT. Below is the truth table, which talks about the two variables' different combination of values and the results of the main three logical operations. And also please note the graphical notation used for indicating each operations. Just a note that when computer engineers are designing processors, they rarely work at the transistors level and instead work with much larger blocks like logic gates and even larger components made up of logic gates. It is one of the greatest video which explains how computer add numbers. Please note that the addition is done with the help of multiple logic gates combination. My intention is you don't need to really know the complete implementation about adding number. Instead, if we know that the addition is done with the help of logic gates is enough. But it is always good if we know the complete implementation. Please watch the video I have mentioned in the reference for that exact implementation details. This is also another good video wherein you can get to know about introduction of Boolean algebra. Please look at this video as well. It talks about Boolean logic and logic gates in deep. Binary number system. In mathematics and digital electronics, a binary number is a number expressed in the base 2 numeral system or binary numeral system, which uses only two symbols, typically 0 or 1. The base 2 numeral system is a positional notation with a radix of 2. Each digit is referred to as a bit. Because of its straightforward implementation in digital electronic circuitry using logic gates, the binary system is used by almost all modern computers and computer-based devices. Please have a look at the pictorial representation of base 2 integer number and base 2 floating point number. To represent other than numbers like letters, special characters, and control characters, we need to have a standard. That's where ASCII and Unicode comes into picture. ASCII, abbreviated from American Standard Code for Information Interchange, is a character encoding standard for electronic communication. ASCII codes represent text in computers, telecommunications equipment, and other devices. Most modern character encoding schemes are based on ASCII, although they support many additional characters. Unicode is an information technology standard for consistent encoding, representation, and handling of text expressed in most of the world's writing systems. If you are interested to know more about how the numbers and letters with binary are represented in the computer system, then I would suggest you to watch this video. And if you are interested to know more about binary number system, then please have a look at this video as well.